How are you doing, all you amplifier nerds out there? Welcome to another episode of Martin's Tube Amp Workbench. And this time, again, we have a superstar called Kitty Hawk Standard on the bench. As I mentioned in a previous episode about a Kitty Hawk Custom, this company started in the late 70s as a distributor for Mesa Boogie and Dumble amps in Germany. And when they started to make amps on their own, they borrowed a lot from Mesa and Dumble. So there is still a rumor going on that these amps are still a poor man's Dumble, though they are still pretty expensive. A quick look at the output transformer, and we know this amp was born in 1987. Well, in 1987, Ronald Reagan and Mikhail Gorbachev signed a contract to eliminate nuclear weapons. Well, Ronald's Kitty Hawk amps are not that bad, but yes, they are a repairman's nightmare, and you will see that later on. Let's hope that my repair lasts longer than the friendship between Russia and the US. But now let's take a look at the front panel. Okay, we have a boost switch, a treble, mid and bass switch to enhance the frequencies, a master volume, a rhythm and lead volume, a presence control, a three-way equalizer, and the reverb control, and a selector switch to select between 150 watts standby and mains. This is the back panel, the fuse, the mains, send and return for effects, preamp out and in, slave, the weird foot switch, input, and the inputs for the speakers. And again, when you look at the design, it's very close to the early Mesa Boogies. Okay, let's find out what the problem is, and let's put Kitty on the bench. Got my dummy load hooked up and my current limiter. Let's see what happens when I power it up. Whoa. Oh, the current limiter shines pretty bright. That's an indicator for a problem in the power supply. And look what happens when I turn up the volume knob. The current limiter shines even brighter, and the control limb cuts out. So it's definitely an issue in the power supply. We have to take a closer look at the HT caps. And here is the next issue, a strange crackle when I turn the mids knob. The parts in these amps are pretty crappy, plastic housings, and look at this. Look at this. The housing of this part is completely loose. You can wiggle it around. So this is issue number 3. Though the rest of the parts seem to be fine, we have to consider a little cleanup. And we have to replace the mids part that's crackling and this one with the loose housing. Might be a good idea to clean the rest of the pots. Yeah, but it's hard to get the cleaner in because everything in this amp is very tight. But let me give you a short overview now. Let's take a look at the circuit. Again, like in old Mesas, we have a few independent circuit boards connected with a bunch of wires. Here's the so-called switching board with a bunch of ICs. Here's the preamp board. And this is the bias supply and another board for the power supply. And last but not least, we have another board for the power tubes. And here we have issue number 4. Look at this. One of the filter capacitors is cracked. I've never seen something like this before. Here I'm checking the solder joints of the tube sockets. And well, they used standard sockets with solder lugs, bended them around and soldered them directly to the circuit board. That can cause problems because the lugs are under tension and they get very hot. So sometimes they come loose. But in this case I got lucky. There is not an issue here. Alright, let's check the screen grid resistors. We should reach 470 ohms, but they are all a bit high, as you can see. More than 500. Oh, this one is extremely off. Instead of 470, we reach 755. And the last one, yeah, it's out of tolerance too, so we have to change them. Here is a closer look at the drifted resistor, and you can see a spot on top. It might be a burn mark. So this is issue number 5. Here I'm testing the grid resistors. They should have a value of 3.3K. Here we have 3.4. That's fine. Oh, 3.3. Nice. And the last one. Oh, it's hard to reach. Oh, come on. All right. Fine. 3.4. That's pretty good. The dropping resistors are in spec 2. 12K, and the other one should read 2.2K. Yeah, close enough. That's fine. Oh, here is issue number 6. The bypass capacitor down there is leaky. Look at the grime that's creeping out this cap. But let's get started. I'm going to change the screen grid resistors. Okay, let's push the fast forward button, and here you can see some of the new bypass capacitors already in place. The one on the left side, the ITT branded cap, is still waiting for replacement, but it's hiding under a bunch of wires. I have to get them out of the way first. Okay, that's better. The old HT caps are ready to go as well, and you can see it's really necessary to replace them. Look at this. Say goodbye. Magic. Here they are already replaced with nice F&T caps. And here's the next one on my list. Again, an old Mallory. I'm sorry for the shaky camera. These two caps in the bias circuit are waiting for retirement too, but changing them ended with a disaster because a ton of hot glue that somebody spilled all over the place. When I tried to remove them, all the components in the neighborhood sheared off. Look at this mess. But with a little patience and time, eventually everything was back on board again, cleaner and more stable than before. And here is the revised circuit. All the electrolytic capacitors are replaced. The bypass capacitors are replaced too. And the screen grid resistors are brand new. Looks pretty good to me. Well, I ordered 2 new potentiometers for the bass and mids control. Well, it's no big deal to swap them out later. And now it's time for a part that's always fun for me. It's tube testing time, the Triple T. Because I love my old tube tester from 1966. If you would like to know more about my trusty old tube checker, how it works, then I put a link down below to a video that digs deeper into this subject. Well, as I expected, the bunch of tube amp Dr. tubes tested perfectly fine. Kitty Hawk amps, likewise old Mesa boogies, do have a non-adjustable fixed bias. Though we cannot adjust the bias, I would like to know how it is set up. We have a plate to cathode voltage of 480 volts. I set up my amp meters. And look at this. We have a nice matching of around 32 milliamps. That's actually on the cool side of the range. If it was adjustable. We could go up to 42 milliamps without no problems. But hey, it's not adjustable. Another thing I would like to take a look at is the sine wave. So let's hook up the signal generator and the oscilloscope. Well, yes, looks perfect. A very clean sine wave. But how about the overdrive? Let's take a look at this too. Again, nothing to be concerned. Everything is nice and clean. Yeah, it works. But another issue is yet to come. The reverb does not work at all. To find out what's causing the problem, there are different components to check. So I changed the reverb driver tube with no result. Then I checked the little coils at the end of the springs inside the reverb tank for continuity. They tested fine too. So the reverb transformer crossed my mind. The schematic of a common Fender reverb circuit shows us that we should read a high voltage on both sides of the primary winding, like here, 400 volts. So let's see if I got lucky. Oh yeah, 489 volts on one side of the transformer and nothing on the other side. So it seems to be it's open circuit, but let's double check it. Let's check the primary for continuity. The secondary winding shows 1.5 ohms. All right. The primary shows open circuit. So the reverb transformer is blown. And now let me show you a little trick how you can test your reverb tank without removing any component. Especially the two transducers at the ends of the springs tend to fail. And this method is easy and crude. Just bounce the cabinet with the reverb tank installed on the ground, on the table, or whatever. If the driver transducer is alright, you can hear the springs rattle and reverb. Then reverse the leads in the RCA jacks and bounce again. The noise is quieter, but you can hear it. If you hear nothing, rattle or reverb in the speaker, the transducer is faulty. Well, that's it. 8 issues in 1 amp. Not too bad, huh? But now it's time to listen to the Kitty Hawk standard and see how it sounds like.